The second one is going to involve a similar process. It's going to look a lot like this one, except for the fact that we are going to have to replace the top, first of all, using a Pythagorean identity. So tangent squared, or whenever we see something squared, I like to look at the Pythagorean identities. Here's the one that we're looking at. 1 plus tangent squared equals secant squared. So what we're going to do is we're going to replace tangent squared with something involving secant. Now, in order to do that, we need to get tangent squared by itself. So we're going to rearrange this one a little bit. We're going to take the 1 and subtract it to the other side so that tangent squared is isolated. That means we have secant squared minus 1. So now we're going to take, in this problem that we have, we're going to move tangent squared x, we're going to replace that with secant squared because of that identity, secant squared minus 1. And so then we have on the bottom secant plus 1. Now, kind of like this first example again, we have the difference of squares pattern, just like from here to here. So in the next step, we're going to take the secant squared minus 1 and we're going to split it up as secant plus 1 and secant minus 1. On the bottom, secant plus 1, and you can probably already see how similar this is to the last one. We have an entire factor that can be canceled out, so those two are gone, and we just get secant minus 1 left over.